Hey friends, in this lesson what we'll try to basically understand is is basically derive the relation between bulk modulus and Young modulus of elasticity. And the other relation, that is between the shear modulus and the Young modulus of elasticity, can be seen from any book. Now, the relation is like this: K is equal to nothing but E by 3, 1 minus 2 times this. Now this relation, to get this relation, we need to understand a basic concept. For example, this is a body subjected to a biaxial spread of stress. If this is sigma x, this is sigma y, suppose. Sigma x. This is sigma y again. Now let us try to find the strain along the x direction. The strain along x direction will have two components. Number one, the strain along x direction due to x, that is sigma x, minus the strain in x direction due to y. Now why minus? Because the stress in y direction will have some sort of a contractual effect in x direction. So this negative sign. Now mu, as we know, is equal to nothing but change in lateral dimension, that is in this dimension, that is given as epsa x y by the change in this direction to which the force is originally acting, that is epsa y. So epsa x y is nothing but mu epsa y. So I can replace this epsa x y as mu epsa y y. So essentially this is one relation that I need to take care of. So I will write it here: epsa x xx minus mu epsa yy. Now let us take this body, right? Now this body is subjected to forces from all sides. Suppose it is subjected to P force from this side, P force from this side, P force from this side, and also from the other three sides, right? And if my coordinate axis is like this, x, this is y, this is z, suppose. Then, if I want to find the strain basically, then this volumetric strain, or I should say it as EV, is nothing but epsa x plus epsa y plus epsa z. And each of this will have three components again. Now epsa x, suppose, will have a component of strain along x direction, and there will be some sort of a negative because of this force will have a tensional effect in this direction, so it will be negative here, minus epsa yy minus mu epsa zz. Now as all these p's are same in magnitude, so I can write it as p by e minus mu p by e minus mu p by e. So essentially p by e is common and 1 minus 2 mu. So epsa x is nothing but p by e 1 minus 2 mu. And similarly this thing we can get also for epsa y and epsa z. One can try it. Now so essentially it will be equal to 3 times epsa x. So 3 p by e 1 minus 2 mu is EV. Now P is nothing but KEV, and K is equal to P by EV. So P into E by 3P 1 minus 2 mu, right, is equal to K. And this P cancels out, so I'm left with E by 3 1 minus 2 mu. And essentially this is the relations we wanted to derive. So this is all about stress and strain analysis. Now from the next lecture the real game will start. The concept of bending, the concept of torsion, the concept of column, the concept of beam, all these things. These are pretty difficult things. So till now what we have done is basically the basics of strength of material. Unless you have this in place, you won't be able to walk down the road. So this were the basic, the principal stresses, the Mohs circle state of stress, and all these things. One must know all these things, and from the next lecture I will introduce the concept of bending. Thanks a lot for listening. Thank you.